Hello learner, welcome to Manifested e-learning platform. My name is Purity Anzelimo. Our subject is physics and our topic is waves 1. This is a continuation of what we have been covering in this topic. In our previous lesson, we looked at transverse and longitudinal waves, and we were able to explain the two, the transverse and the longitudinal waves. And we were able to distinguish between the two, and we were also able to give examples. We say transverse waves are waves whose vibration of particles is at right angle with the direction of wave travel, whereas longitudinal waves are waves whose vibration of particles is parallel to the direction of wave travel. So during our lesson today, we want to look at phase and phase difference. Phase and phase difference, that is for waves, and we want to see when you are told, for example, to draw or to make a sketch of a wave, two waves whose maybe amplitude is the same and the frequency is different. What are you supposed to do? Then again, by the end of the lesson, you'll be able to know what we mean by talking of waves which are in phase and waves that are out of phase. So to start with, we can say that waves can be of the same amplitude. Waves can be of the same amplitude but different frequency. Or we can also say that again, waves can be of the same frequency but different amplitude. So waves can be of the same amplitude but different frequency. We say the frequency is determined by the vibration of the source, which is the vibrator. Then waves can be of the same frequency but of different amplitude. And we want to make the two sketches and see how the wave looks like. So we start with the first one. We can even call this one number 1 and this our number 2. So we start with number 1, waves of the same amplitude but different frequency. We know what is amplitude, we know what is frequency, and therefore it becomes easy now to make a sketch. So we have displacement, against time. We can give displacement in meters, and this is time in seconds. And we have this wave here. So we can consider this wave, that's our wave. So we want to draw a wave, another wave. This is the first one. We want to draw another one which is of the same amplitude. Amplitude is the distance, the maximum displacement from the mean position. So it should be of the same amplitude but of different frequency. And frequency is the number of complete oscillations in 1 second. So the number of oscillations is going to be different now. So by the time we get to this point, here in the first wave we have 1.5 oscillations. So we want now to change the frequency. It can be more or less, but the amplitude to remain the same. So we can have our wave as follows. So you can see the amplitude is the same. The amplitude is the same, but when it comes to the frequency, as you can see now with the blue one, we can determine the frequency. Let's see how many oscillations. If assuming that this is 1 second, how many oscillations are these? We have 1, 2, and a part of it. But in the other one, we had only 1.5. So you can see clearly that it is of the same amplitude, but the frequency is different. So we can draw the second one. So this is the first one. The second one is waves can be of the same frequency, but different amplitude. So number 2, we can have the following: a displacement time wave. So that is the wave, and in this part they are of the same frequency but different amplitude. So like this one, we have how many oscillations? 1.5. So the oscillations will remain the same, but now the amplitude is the only one that is going to change. So we are going to have it as follows. So we have the amplitude. We can make it more. Like in my case here, I'm making the amplitude more, but the frequency should remain the same. So that's how my wave is going to look like. This should be a smooth one. So you can see clearly that the first wave, the amplitude is at this point, whereas for the second one, you can see where the amplitude is. So they have different amplitude, but the frequency is the same. If you look at the black one, it's 1.5 oscillations in the time given. The other one is again 1.5. So the frequency is the same, but the amplitude is different. So you need to make note of that. Then we can now define what we mean by saying that the waves are in phase. So waves being in phase, what does it mean? And also out of phase. So we can start with in phase. Then we give some drawings or some sketch for the waves. So we say that a wave or waves are in phase when the particles in a wave motion oscillate in the same direction and at the same level of displacement. So when they are in phase, we are saying that the particles are oscillating they are oscillating in the same direction. So, and we are saying that if they are oscillating in the same direction, that is of the level of their oscillation, then we can have the particles as follows. That is in phase. We can have a graph of, this is displacement. Against time. So if we have our wave, so this is what we are going to have. So if we have our wave, we can even start it from here. So we can have our wave as that, and we can say that the particles are oscillating in phase. So for this one, the particles are oscillating in phase. We can also have a wave whereby they are oscillating in phase, but the amplitude is different. We can have a case like this one here, whereby the particles are also in phase, but now the amplitude is different. And we can also say that it is also in phase. The wave is in phase, so we have this. So displacement against time. So we have our wave as follows. So if we have our wave, we can start it from this side. So if we have such a wave, we can also have another wave which is in phase but of different amplitude. So we are going to have another phase which is in phase but of different amplitude. So we can make it of a smaller amplitude that way. So we can say that they are in phase but they are of different amplitudes. So that's simply what we mean by in phase. They are moving in the same direction. Then we can define out of phase. When we say that waves are out of phase, we have said for in phase the particles are oscillating in the same direction, whereas out of phase, in this one the particles, they are oscillate in different directions or in opposite directions. They oscillate in different directions, and we can give an example of waves which are 180 degrees out of phase with each other. 180 degrees out of phase. So an example, we have 118 degrees out of phase. So we can have such a sketch of oscillations that are 180 degrees out of phase. These are oscillations. So in this we have the following. This again displacement against time. So I told you this not drawn to scale. So if we have a wave from this point here up to there, if we want to draw another wave that is 180 degrees out of phase to this one, we have seen that we are drawing it in the opposite direction. So we are going to start from here. So we move this way. 180 degrees out of phase. So that is it. So we are going to say that here the oscillations are 180 degrees out of phase. So you can see now it is in opposite directions. So you can be asked or you can be given a question, for example, where you are given a motion like this one, you are given a wave like the one that you have been given here. You can be told to draw another wave whose amplitude is different from this, or maybe the frequency is double this, but the amplitude remains the same. Or maybe you are told that the amplitude is double this, but the frequency is the same, so you shouldn't be in a position to. You can also be told to draw a wave, maybe which is 180 degrees out of phase, so you shouldn't be in a position to. Again, you can also be told, and this one you can answer, you can also draw one whereby the oscillations, draw a wave whereby the oscillations are at 90 degrees out of phase. So I'd like you to have this sketch. So you start with the first wave, you draw the first wave. I can draw the first one. Then using the same, you draw another wave which is 90 degrees out of phase. So to start with, you can have the following. So whenever you are drawing a wave, it's always going to mark the lower and the upper part so that they are of the same amplitude. So for example, if I have a wave like this one here, so you can have such, and then you draw some oscillations which are 90 degrees out of phase. So you can try this. You have done the one for 180 degrees out of phase. You can try this for, so using the same sketch, you just come and plot. Well, now we have 90 degrees out of phase. So that is it on phase and phase difference. We say that waves are in phase when the particles are oscillating in the same direction, whereas they are out of phase when they are operating or they are oscillating in opposite or different directions. You've also been able to understand that we can have a wave on waves which have the same frequency but different amplitudes. We can also have others that have the same amplitude but different frequency. And you shouldn't be in a position to plot that. So thank you for following till we meet during our other lesson.